The point of Lab 1.2 was to compare the difference between the mean of a population and the results we get from good sampling. We also recall that convenience sampling or voluntary sampling are not effective because they are not random. The point of random sampling is to ensure that we represent the entire population. If we take a census and average the area of every rectangle, and you recall that I called the 100 rectangles the village. If we take a census, then the parameter for the average size is 7.42. Now, in general, one of the random sampling methods should be closest to the size of the average rectangle. Random sampling in general gives us the best results. When we choose such a small population and such small sample sizes, your mileage may vary. Sampling bias occurs when one part of the population is ignored or favored. This results in the statistic being over or underestimated. What kind of bias did we show in our exercise? We did show some sampling bias. Now, we do need to know the random sampling methods because depending on the statistics in which we're interested, we may choose one sampling method over another. In a cluster sample, we divide everybody into groups, we number the clusters, we choose random numbers, and every individual in every cluster that we choose out are going to be included. One time to do a cluster sample would be to look at geographic differences in rates of cancer or voting patterns. A systematic sample, the example I gave of systematic sample is having lots of people coming out of a polling place on election day, or many hundreds of people lined up to enter a sporting event or a concert. In a systematic sample, we number off the first 10 or 20. How big a sample do we want? We choose a random number between 1 and 10 or 1 and 20. That identifies the first individual for the sample. And after that, we just add 10 more, and then 10 more, and then 10 more, until we have our appropriate sample size. Simple random sample, we number every individual in the population. We choose out random numbers equal to the number that we want for our sample, and those are the individuals identified to be measured. In a stratified sample, we group people together based on similar characteristics. In this course, we're not going to consider more than 2 groups at a time. For example, men versus women. For example, African Americans versus Europeans, Caucasians. For example, babies versus teenagers. Anytime we want to see whether a medicine or a technique or some other measurement works differently in one group than the other, we use stratified samples. Another way to draw a random sample is to use a table of random digits. This is a table of random digits, and this was especially popular before the advent of well-written algorithms. When we use a table of random digits, we select which line we're going to use. They're numbered for convenience to make it easier to read. Now, in our example here, we're going to start with line 4. We determine how many digits we need to use. The fewest number of digits that will accurately reflect our whole population is the best. We have 100 rectangles, so we will number them 01 to 99. What do we do with 100? We use 00. Now we write down the sets of digits, and of course if we get any repeat digit, then we're going to ignore that because it's not appropriate to measure an individual more than once. So here, the rectangles we would choose out are 42, 16, 79, 30, and 93. We also notice that the digits may be grouped by fives, but that is only to make it easier to read. It has nothing to do with the way we use a table of random digits to choose out random individuals. Oh, if you want to do this on a TI calculator, assuming that we get back to real life at some day, you press Math, you scroll over to Probability, you scroll down to Random Integers. The first number is the smallest you can use. The second one is the max. Now, if you're using a TI-83, you'll have to separate your numbers by commas. We enter the minimum number and the maximum number. If we need more than one number at a time, we enter the number of integers we want to choose. Please remember we have to ignore repeats because we cannot measure the same individual twice. That skews the data and it's bad sampling. Then in the lab, we decided that one good way to do this was to use random.org because the algorithm is excellent. And the easiest way to get there is random.org/integers. Thank you for your time.